all the time to look at, but we're just not quite there with our graphing skills yet. So remember, we ended yesterday talking about the different types of symmetry. It is very important to kind of know what these definitions mean. If it is symmetric to the y, we're saying it is a mirror image across the y-axis. So if I took my paper and folded it over the y-axis, both sides overlap. If it is symmetric across the x, it's a mirror image on both sides. Okay, origin requires two flips. You have to flip it over the y and over the x. We talked yesterday about what happens with the ordered pairs. So if you are flipping it over the y, when x is positive and negative, you get the same y value out. So y for a positive x and y for a negative x are the same. Another way of saying that, f of positive x is equal to f of negative x. If we put in a negative x to our equation, we get the exact same answer out. If it is symmetric across the x, when x is a number, you get both the positive and negative y. So if I put in a negative y, I get my exact function back. Origin, our points are total opposites. The x changes sign and the y changes sign. So we're going to change our signs on the x's and the y's. So in terms of talking about the equations, there are different options. If your graphing skills are good, you could draw a graph and look at it. And we'll get to that point, but we're not really there yet for graphing all these different things. But if you can think back to what it means when I tell you to check the symmetry. If I want to check symmetry to the x-axis, okay, if a graph is symmetric to the x-axis, that means it's the same on both sides. So if I put in an x, I have basically the positive and negative y. Would you guys agree with that? So what I'm going to do is we are going to replace y with negative y. So this is, I had that notes handout yesterday, we finished it, so you're in your notebooks now working these last few examples. So if I go to my equation, and I put in a negative y for my y value. So go to the actual equation, replace the y with a negative y. I need everybody to make sure you understand what I'm doing here. I'm not just putting a negative on that side of the equation. I'm taking out the y, putting in a negative y. Okay, what happens if you do the absolute value of a negative? It turns into positive. So this is the same as the absolute value of positive y. Would we agree with that? Is this the same as my original equation? Yes. So that means even if y is negative, we have the same thing back. So this graph is symmetric to the x-axis. You plug in a negative y, you see if you get the same thing back. To check the y-axis, okay, if something is symmetric over the y-axis, then that means if you have one y value, you have the positive and negative x that corresponds with it. So what we will do is replace x with a negative x. So we're just making the opposite variable negative. If I put in a negative x, okay. Is that the same as my original equation? No. Is there anything I can do to make it the same as my original? No. So this one is not symmetric to the y-axis. For origin, we have to do both. So we replace x with negative x, y with negative y. Because it's two flips, both x and y change sign. And I'm trying to see, can I turn this back into my original? Okay, I can't do anything about my x. When I do the absolute value of negative y, that's the positive. But again, is this what I started with? No. Now, as you do more of these, you'll get to the point where you will probably start to catch on and maybe won't have to write out a whole bunch of work every time. But for now, I'm trying to make sure everyone understands what we're doing. So we're checking if it has that symmetry, both the positive and negative should equal the same thing. So you're just plugging in a negative for the opposite variable there. Alright, so B. If I want to check the x-axis, what do we do? Replace the y with a negative. It's the opposite variable. Okay. Is that what I started with? No. Is there anything I can do to get rid of it? No. So this one is not symmetric to the x. If I drew the graph, it would not have that symmetry. If I want to check the y, we make our x's negative. Notice I'm putting them in parentheses because I'm replacing each of those x's with a negative x. Alright. If this confuses you, a couple people in my second hour were confused when I said like negative x to the third. You could think of that as negative 1 x to the third if you want. What's negative 1 times negative 1 times negative 1? Negative 1. What's x times x times x? So we have a negative x cubed. If you have a negative to an odd power, it's still negative. Okay, then negative 2 times negative x is positive 2x. Is that what I started with? No. So is this symmetric to the y-axis? No. Okay, origin. We do both. We make the y negative and the x negative. Okay, we just worked out the negative x to the third is negative x cubed. Minus 2 times negative x is a positive 2x. Okay. Is there anything I can do to turn that back into what I started with? If I take both sides times negative 1, get positive y, positive x cubed, minus 2x. Is that the original equation? Yes. So this one is symmetric to the origin. Do you guys all understand how I'm doing this? Okay. Let's do one last problem like this. Alright, x squared plus y squared equals 25. So if I want to check the x-axis, what do we do? Make the y negative. What is negative y times negative y? So, is that what we started with? Yes. So this graph is symmetric to the x-axis. We check the y. We make our x negative. What happens if you take negative x times negative x? And so we see what? It's the same. So this one is also symmetric to the x. Or sorry, to the y. So we have both so far. Origin. And we've already seen when you square a negative, it's positive. So this one is also a yes. This graph has all three types of symmetry. So you can have more than one. You don't have to have any. So they can all be yeses, they can all be no's. You will never get like 2 yeses and 1 no. If it has 2 yeses, the third is guaranteed to be a yes as well. But otherwise, we don't really know, so we have to check them all. All right? Are we okay with that? So what we're doing, the symmetry, when we're talking about functions, there's terms associated with it that mean the same thing but apply specifically to functions. If we think back to our types of symmetry, if you're symmetric to the x-axis, is that a function? No, that one fails the vertical line test. So the terms involving functions are talking about the y-axis and the origin. So even is the same thing as symmetric to the y. That means if it's symmetric to the y, if you plug in a negative x, you get the exact same answer out. So whether x is positive or negative, your answer is the same. This is going to be very useful on the Math Excel. There's a lot of questions where it just has you pick something from a drop-down menu, so it'll say this function is even or odd, and you select the one, and then it's going to have these for your definitions, so make sure you jot those down. Odd is the same as symmetric to the origin, so I just always remember odd is origin, okay? And those are opposites, odd, origin, opposites. If you put in a negative x, you get a negative y. So they are total opposites, both the x and the y. Change signs. So just another way of referring to symmetry, but specifically dealing with things written in function notation. So I want to take a look at a few graphs and decide if these would be even, odd, or neither. All right. So, even is symmetric to the y. Odd is symmetric to the origin. If I look at this first graph, what would that be? This one? So here's my y-axis. Is it the same on both sides of that y-axis? Yes, so it's symmetric over the y, so that would be even. Do we see that? Remember, your y is your vertical axis. Okay, second one. If it's symmetric to the y, that means if I fold it over the y, it would look like this. So it's definitely not even. Odd says you flip it over the y and over the x. If I take that dashed line and fold it over the x, it overlaps my original. So that is odd. Symmetric to the origin. All right, this one. So I think if I flip it over the y, okay, definitely not what I started with. If I then flip that over the x, does it overlap the original? Yes, so this would again be odd. Last one. If I flip this over the y, so it would look like this. If I then flip that over the x, so this point would go all the way up here. It's going to look like that. Is that what we started with? No, so this is neither. Okay, so kind of a visual. If we're looking at the graphs, we're checking that symmetry. Is that okay? All right. So if I want to decide if these are even or odd, it's really just checking the symmetry. So we have two options. We can change f of x to y and do it like we were doing before. If you want to check the y-axis, you make your x. If you want to check the origin, you do both. We could also just straight use the definition of even and odd that we wrote down. So both of them require us to put in a negative x. If you plug in negative x and get your original equation back, it's even. If you get the exact opposite, it's odd. If you get anything else, it's neither. So if we try that, it's just a little bit faster, but kind of the same idea. If I put in a negative. What is negative x times negative x? Is that what we started with? Yes, and if we have what we started with, it is even. It's the definition of even. If I put in a negative x cubed. So negative x times negative x times negative x. If you multiply three negatives, your answer is negative. And x times x times x is x cubed. Okay, is that what I started with? No. Odd says they have to be total opposites. So is that the same as taking my original one by times negative 1? No. This one is neither. Alright. The last one here. So if I put in a negative x, so we did it up here as well. Negative x times negative x times negative x is negative x cubed. Minus a negative would be plus x. So 5 times negative x cubed would be negative 5x cubed plus x. Is that what I started with? No. Is it the exact opposite? Like taking this original times negative 1? Yes. So this would be odd. Okay. Are you guys catching on? Okay, here's what I want to do. Because it seems like this is very confusing for people. In the past, anyway. So, before we get into homework, I want to kind of give you guys some practice. But I want you to work with people so we actually like have conversations. So let's put like 2, 3, 4, I don't really care. Just nobody's working by themselves. I want conversation. There's a handout posted on Google Classroom. Okay? I just want you guys to try it, talk through it. I want to give you a few minutes. If you don't get all the way done, that's fine. We'll start talking about it as a class in a little bit, but I want to kind of give you guys a chance to talk through it and see where our problems are arising. So the first ones, if you were to take this point and flip it over the x-axis, it goes to positive 5, positive 3. Right? And haven't we been saying if it's symmetric to the x, the y's are opposite? That's what happened. If you flip it over the y, then it becomes negative 5, negative 3. Because if it's symmetric across the y, your x changes sign. Origin changes both of them. If I flip it over the x and over the y, it ends at negative 5, positive 3. Okay? So A, symmetric across the x, would change the sign on your y, so you get negative 6, negative 1. Across the y, positive 6, positive 1. Origin changes both. 6, negative 1. Do I need more explanation on those two? Okay. On these, we don't necessarily have to do all of them. I just want to kind of make sure we're on the right track. How do we check for each of these types of symmetry? Okay, so to check your x, you make your y negative. Is this the same? No. To check your y, you make your x negative. But if you square a negative, it becomes positive, so that is what we started with. To check origin, we do both. Okay, negative x times negative x is positive x squared, but we still have that positive y, so that one's a no. So this one is only symmetric to the y. Do we get that? Number 4, what do you think that one's going to come out to be? Yes, yes, yes. If you make, to check your x, you make your y's negative, but a negative squared is positive. To check your y, you make your x negative, but a negative squared is positive. Origin is both, and they both become positive, so that one's all yeses. What do you think about 5? Check x, you make your y negative. Does that work? check your y, you make your x negative. Does that work? To do origin, you do both. Does that work? No. So that one's all no's. Right. Are we okay on those? So even and odd is essentially the same thing, but it's a little bit easier if it's written in function notation, because all you have to really do is f of negative x. So if I put in a negative x, a negative to the fourth power is that what I started with? Yes, so that means my function is. Okay, if I look at this one, if I put in a negative x. Okay, and negative x times negative x times negative x, that's still negative. But negative 4 times a negative would become positive. So what does that mean? Odd, because it's the opposite of what we started with. All right. Are we catching on, or do I need to do more of these? Catching on? Okay. So I'm going to stop here. There is a math Excel assignment open, and you have the next 20 minutes to work on it and ask questions.